welcome to my session here at the Techno Day in 2022. I'm so glad you're spending your time with me here, even though it's just virtual, but we will keep up with some other meetings later on, hopefully. So, thank you so much for basically having interest in learning about visual testing, which was a lifesaver for me when it comes to refactoring my front-end applications lots of time. But I won't be too far now. Let me please introduce myself at first, or let me introduce the talk in afterwards. I'm Ramona, and welcome to the premiere episode of Mo Presents Fun with Tests. Well, Mo is a nickname of me, but let's get serious. I'm working as a front-end developer at Shopware, and Shopware is a company providing an open-source e-commerce platform. But apart from being a front-end developer for some years now, I have 5 years of experience in quality assurance as well. So you might have guessed, due to that, I'm quite passionate when it comes to test automation. And I want to strengthen the trust and the developer and tester's experience when it comes to that. And that led me to becoming a meetup organizer and even a Cypress ambassador. So yeah, that's something about the least important person here in the room. Let's get started. Well, if you think about being a developer and working on your application, or even thinking about being a user of such applications, you will sometimes stumble across some bugs that might not be release blocking, bugs which are small UI errors or typos, all those small things looking kind of ugly, but not that important, right? Well, there tend to be many and they can happen everywhere. And they will leave a shattered impression if you don't fix them. See this one. You have a screen of an iPhone, I guess, where you see the string inside of the central thing, saying keine Mitteilungen or no notifications in English. And it's quite obviously broken, right? It's doubled. And as it's from an iPhone, from Apple, you can guess that this can also happen to a lot of other, even larger companies like Google, for example. Take a look at this little button here on the phone's location. Or Facebook, where you see the blue button having a quite unusual padding, right? There are so many examples, and this is nothing bad because it's nothing usual, right? I'm not so sure if it's nothing bad because it's not only my own perfectionism as a front-end developer seeing all those little things and which are triggering myself a bit. I wonder something as a developer and a user like, would I or would you trust those applications? Not yet these examples, but in general. Would you trust an application which looks broken or doesn't show any signs of care to begin with? Would you entrust such an application, for example, your credit card data? Especially when it comes to the following fact. Would you think that such bugs will be fixed quickly? Well, in a perfect world, of course, yes, but in practice, no, unfortunately, because they don't break functionality, right? Look it from the other side. If you have a team fixing lots of those small bugs, you can be sure that it will keep teams away from building the actual features and improving the application in other aspects. So it can be considered a growing technical debt. And that makes it even more bad because over time, the trust is lost by the customers, by the users. It's waning, and we don't want that, right? It's a bad situation. But are we as developers or as testers really to blame? You could say, yeah, because someone did the error to begin with, or a tester failed to notice it, right? Or not? Well, we are all human, right? We do mistakes. But can we do much about it besides improving our shortcoming? Well, there's a well-known phenomenon in psychology, which is the culprit in most cases. There are many videos showcasing this phenomenon. The most famous one being "Who Done It" by Do the Tests. I guess it was recorded for a UK traffic campaign, and there are others by them as well. And one of those I saw in my psychology class in university. So in the video, there were people into teams, and all of them wear some white and some black t-shirts. And those people were busy with passing balls to each other. And us, or me as a spectator, was supposed to count those passes. And while they were doing this game and we as a spectator were counting them, a person in a gorilla disguise walked through the picture and was doing moonwalk, like something like that. And believe me, it was really obvious. But it was still the fact that about half of the viewers do not notice this person in a gorilla costume. And this is this phenomenon which I meant, like being the inattentional blindness, which means that the person does not perceive an unexpected stimulus in the vicinity solely due to a lack of attention and not due to visual defects or deficits or anything else. Imagine working on a front-end feature and you are not able to see a huge typo in the first heading of your page, right? I guess lots of people experienced that before as well, including me. But now you could ask me, to prevent such human errors, we have good test automation, don't we? We are using unit tests, integration tests, end-to-end tests, all kinds of tests. Shouldn't they catch those, especially those because we are so human and we do mistakes? Well, it's kind of true, but not when it comes to UI issues or typos because they aren't considered important, right? So I would answer with a no, because your test can be perfect, but it will only test what they are told to test. Basically, only the things you wrote down as a test author when it comes to that. I like to sum it up like end-to-end tests do not look left or right, so lots of things will remain undetected, if not explicitly written down. And it's targeting basically anything outside the concept. And this is the area where you find the actual issues, the actual errors. So yes, this situation is kind of bad, right? But should we just do nothing and accept it? Or how do we solve this problem or this situation? Well, we could think about giving our tests eyes, like we as humans do automatically because we have eyes, we see things, we're interpreting things. Put into other words, we want to have visual testing. Visual testing. What does that mean in detail? What is it and how does it work? Well, imagine it like this thing here. Maybe you know such spot the difference puzzles from your childhood. Well, I love to do them in some, how can I call that? These little sections in magazines where you can have riddles and little games and stuff. I really love those things. And we as human can see those spot the difference puzzles, like this one here in the slides, which I did by doing some small pictures of a shelf inside of my flat. We are able to see the differences in this puzzle, right? Did you already discover them? Well, the beckoning cat here is turned in a different angle. The miniature here, the pixeling, is on the other side of the picture frame. And in general, the image is rotated in different angles. We as human will finally find these differences, but we want to have our test seeing those differences as well and doing basically the same thing, doing a screenshot comparison. A test could think of using a basic screenshot as a base, as a status quo, to determine what's correct, and then take a new current screenshot of your branch, of your change, of your implementation of a feature. And then these screenshots could be compared and the differences could be highlighted. And if we have these differences, this diff or this change, we can decide if this change is wanted or done by purpose or not. So of course, if you merged a new feature, there will be some change because it's the thing you intended, right? So this is wanted. But if it's not wanted, we can reject this change. And the test, in most cases, does not decide that by itself. How could it? Sure, there's some machine learning in there and coming and doing really cool thing, but I guess it won't cover everything. So in my opinion, a review by a human, by us, is still necessary, and rightfully so. You could now say, wow, that sounds great, let's build that myself. There are frameworks in testing like Cypress, Playwright, Selenium, or Nightwatch, or whatever, which have some functionality to take screenshots, right? Let's draw the correct screenshots ourselves, make the screenshots in the branches of our changes, and compare those by ourselves, like writing it ourselves, basically. But is that doable and clever? Sometimes it might be the case, but I guess in most cases, it's not always that easy because it can lead to some problems. It can cause many false negatives. So basically, failing builds without an actual error, just because of the nature of a front-end application. Imagine pixel sensitivity. If something is rendered a bit different or loading differences will take place, you will have a change reported to you. If, for example, your element is just one pixel more to the left. Of course, you can think about add fuzziness via libraries, but do you really want to decide how much fuzziness, how much to ignore is necessary, and how much fuzziness is too much? And you shouldn't underestimate the maintenance efforts as well. Keeping the status quo screens up to date. Sure, there are frameworks and libraries helping you with that as well, but it's still effort. So to give you a little overview about the many tools which you can look at, I gathered some which I found like Applet tools, Percy.io, or Dramatic by Storybook. Or even more interesting, many own community implementations and open source plugins. As I'm working at an open source company, open source is always one of the most important topics for me, so I really love that. So to name some examples is the visual regression tracker or the Cypress image snapshot tool. Strange word. It's derived from the Jest image snapshot tool, but there are lots of others. In this session, I want to showcase you my two favorite tools to give you a little starting point, but I still want to give you some tips later on, which aren't that much dependent on frameworks, so don't worry about that. All right. When it comes to my favorite, it's the visual regression tracker and Percy.io as a software as a service provider. Both of those are tools to manage results of the visual testing. So you will have implementation inside of your test in either case, but the service for maintaining the approval or the rejection or the screenshot comparison by itself will be done by those tools. And what is a really important thing, which is supported by both, is that they are independent when it comes to the automation framework used. So you can use them with Cypress, but also with Playwright or lots of other frameworks to test. First, I want to show you the visual regression tracker because, as I said, it's open source. It's a self-hosted solution, and it's heavily based on Docker, and I love Docker. So yeah, I love it as well. And I want to use Percy.io as a complementary addition here because I use it in my software everyday life, and it's good when it comes to topics for larger applications, but I will cover that in a bit. All right, let's start with visual regression tracker service. So if you want to install this change in approval workflow service, you need to have Docker required. So please make sure that Docker is installed at your machine and download the installed script. And then after just running the script, the visual regression tracker service is ready to be used basically. So you are basically done when it comes to the diff management, but still you need to integrate it into your tests. In this case, I will use Cypress as an example. When it comes to adding the visual regression tracker to Cypress, you can use a Cypress plugin. So they have a plugin for Cypress tests, thus using the default plugin workflow and, for example, installing plugin by npm as package manager. I guess you can do it with Yarn as well, but I'm not completely sure about that. Yeah. But you still need to set up some things before you're ready to start. And yeah, I pre-recorded these setup steps to save you these waiting times, for example, when it comes to typing and stuff. So please forgive me on that one, but I think it might be a bit more convenient. So let's take a look how to set up and prepare the project for a visual regression test. At first, we will start with importing the Cypress commands to later use inside of our tests. Basically, like you are maybe used to integrating Cypress commands, so you will import them from the visual regression tracker plugin. And there are a couple of commands, like for example, for starting the recording, to stop it, to do the screenshot, stuff like that. And then you will add them to use them. All right. The next step is adding the Cypress plugin itself. So quite typical Cypress thing. You will require it in your plugin index file. I hope I am sometime ready to type. I really need something like Jeopardy music or stuff like that to bridge this thing. Or I need to cut better, I don't know. Now I'm ready, and afterwards I will add this constant to the module export to really get it going. Yeah, in this case, in this line. All right. So the third step is the actual configuration in the Cypress configuration file. There you can do some default configurations like the current branch name, the URL for the diff management service, your API keys, stuff like that. It's done in the environment variables of Cypress. All right. There's one step left when it comes to using those visual regression tracker features in your Cypress tests. Yeah, it's about using it inside of your test. So at first you can start this visual regression tracker in the before hook. So it will be started before running all the tests. And afterwards, you can stop it in the after hook, which will be executed after all tests. And then it's simple command usage. Little spoiler alert, this is similar when it comes to using Percy inside of your test later on as well. Just the name of the command is another. All right. When you want to have a snapshot of the whole page, you can use it as a parent command. So basically, as you see here, directly doing a little name, your office page, for example, and that's great. But if you just want to have a snapshot of a certain part of your application, you can use it as a child command. So you will get the elements to capture with the get command. And then you can use the same command, the VIT track command, to really do your screenshot. So it's basically a dual command. All right, how does this look like when it comes to our test itself in the test runner? Here you can see it. You can see what the visual regression tracker commands do. It's basically a Cypress screenshot, so it's using basic Cypress functionality and features as well. But there's one thing to take in mind. If you run your test the first time and thus no baseline is there to begin with, you need to expect your test to fail because you need to review it. So if it fails for the first time, don't get worried. All right. This is the diff management, the change management of the visual regression tracker. So it's basically the screenshot approval workflow where you can accept and decline your screenshots or your changes, basically. On the left side, there's the baseline, so the status quo, which will be the basis for the comparison. And on the right side, your new screenshot. And there you see the menu is opened, which wasn't the case when it comes to the baseline. So we have a difference. It changed to decide if it's good or not. If you want, you can highlight your change in red to see it more easily. And then you can decide to approve it or to reject it. Approve it if it's by purpose, if it's intentional, maybe a new fancy feature or something, or deny it if it's not meant by purpose. All right. Now you know the visual regression tracker for Cypress. I think it's really great when it comes to the usage in a small project, for example, some side project I do and stuff, because it's self-hosted and it's open source, which brings me a bit more independence. But there's one drawback, at least how I saw it. Please correct me if I'm wrong with that, but I have less experience when it comes to continuous integration, when it comes to the visual regression tracker. So it might be less convenient for larger projects. And that's the reason why I brought you another example. It's an example from my everyday life with Shopware. As e-commerce is sometimes a quite complex topic and does complex test cases. And that was basically the starting point for this talk, to find out how to approach such things. So as I said, in my everyday life, I work with Percy.io tests, visual testing, and Cypress tests. So I think I built Shopware's visual testing pipeline a few months ago. It's not that far away, and it had some advantages for us. There was an easy integration into our continuous integration pipelines. So that's basically the point why I use it as a complement, because I wanted to showcase you some CI stuff. There's still a free plan if we need to use it. I guess it's about 5,000 screenshot per month. So if you want to use it with a small project, you can do it as well. I myself do it with my portfolio website, for example, to get some exercise in using it. And many of the Percy integrations and plugins, if not all, not 100% sure if it's all, but many things and integrations of Percy.io are open source. So I still can love it, even though it suffers as a service in parts. Yeah, and it's important to know that it's part of browser stack. So there is a browser stack connection, which can be an advantage as well, because it can help you do responsive and cross-browser testing with and inside of your visual tests. All right, so continuous integration. At work, we are using GitLab as a service for using that. We have an own job for visual testing in our pipelines, which runs currently at night, so every night basically. So we don't have impatient people waiting for it basically. And that includes me. Maybe I'm the most impatient person. I don't know. Let's proceed. We still use visual testing on merge requests as well, but it's opt-in, so the developer can decide if he wants to use visual testing or not. The integration of Percy as visual testing inside of our pipelines was quite flawless. We need to set a token in the GitLab configuration, so we can identify our project against Percy. But otherwise, it's just installing the Cypress plugin, so that's fairly easy. But you don't need to use GitLab. You can use other CI/CD providers as well. For myself, I tried out GitHub Actions, which was quite convenient as well. Here you can see a small example of a GitHub action from the Percy documentation. So it's fairly easy or simple to set up if you use, for example, Cypress Run or anything like that. But there are lots of other pre-configured actions for other testing frameworks in their documentation as well. Coming back to our example, to GitLab, you can see how such a log or such a pipeline job looks like. You will see some Percy entries inside of it. If you are inside of one test, you can see when it did the snapshot. And at the end, you can have the access to the build with the change management. But it's not the only location where you can find the access to your build. You will have it on your merge request as well. So the build is accessible via this job. But again, I would really recommend you to provide visual testing as an opt-in possibility when it comes to your pull request or merge request, because there might be also commits on which visual testing is not that necessary, like little typos or something like that. And furthermore, there are plan limits to consider. So I would really suggest doing that. For the diff, if they detect some changes, your pipeline will become red, so failed, and the merge is blocked. And it will be green as soon as you approve the changes. And it will stay failed if you don't. So the merge is blocked if you need it. A quick overview about the screenshot approval workflow, sorry, in the Percy service. You see, its basics are quite similar when it comes to comparing it to visual regression tracker. So you have your baseline in the left side and your changes on the right side, and then you can, reject your changes or not. Another little recommendation by me, no matter the tool, is to have some notification workflow in place when it comes to having your changes reported to you, especially when you use a scheduled build or use them at a nightly basis. So this is how the testers and developers will be made aware of the changes and can react to that and can accept or deny them, reject them. Yeah, that sounds quite good, right? But well, where's light, there's always some shadow, don't you think? And yes, there were some difficulties and traps I myself experienced. Well, let me take you with them and show all the things I messed up before. But of course, I will provide solutions so you won't step into the same traps as I did. There are two areas which come back to me a lot when it comes to visual testing. The first can be taught in a certain story. It's the story of a boy who cried wolf by Aesop. It's a Greek one, I guess it's from the 6th century. It's really old, but it's still current and really, really important to think of. There's a boy who takes care of a flock of sheep, and he has nothing to do, nothing happens, so he's bored. So he needs something to do, and he gets the wonderful idea of, be careful, there's some irony in it. He shouts, "Wolf! Oh my God, help me, there's a wolf!" without any wolf or any other danger being present. So the villagers come to him to help him and to protect the sheep. But there's no threat to begin with. So the villagers are disappointed because they came for nothing and will go away again. And as the boy pulls this prank a couple of times, in one day, an actual wolf will come and attack the sheep. No one comes to his help. In actual danger, no one will help or protect him, so the sheep will be attacked and eaten by the wolf. Yeah, it's a really dark story, but I guess it's still a good one to explain flakiness to you, which are basically tests failing or passing at different times without any changes in between. And that might happen in visual testing as well, just in another way, in another meaning. But not only that, there's a second situation, which is even more often when it comes to expected false. I already talked about false negatives, which are even more dangerous and will occur a couple of times when it comes to visual testing. There are again tests failing without any error in your application, just because of other reasons. And after all, there might be some changes which are not faulty and not broken, maybe even natural changes, and always but not buggy. There could be changes that cannot be prevented and shouldn't trigger an approval workflow, right? Because we don't want to be informed unnecessarily. And for this one, I love to come up with this topic sometime. I'm so sorry, but it's again time specifications. Those things connected to time can happen in visual testing as well. Think about having a date, for example, in a dashboard application, and running your visual test on a nightly build. Your date will change from yesterday to today to tomorrow, and this date inside of your dashboard will change accordingly, which is a diff. A change which needs to be rejected or approved, right? And it will happen even more often if you consider hours, minutes, or even seconds, right? So we don't want a change approval workflow triggered for everyday change. A possible solution is freezing your time on client side and set it yourself, so basically faking it. In this example, I'm doing it with the Cypress clock command and basically using the date January 1st of 2018 to be used in every build I use. So no change will be triggered. All right, next one, loading times. Think about the following questions. What will happen with my screenshot if my website is still loading, sometimes on the load or on a more slower machine? What happens if the element is still rendering or the UI is still changing? Am I really taking the right snapshot, the right timing? And is the app ready for being taken a photo of? Well, you can imagine if you have a slower build machine or any load or whatever, this might cause some flakiness because today the snapshot has this loading indicator in it and the next one won't. So this is the main cause of flakiness in visual testing. And yeah, the solution is said quite easy, but yeah, sometimes it's a bit tricky, but you really need to make sure that all loading times are finished and all the corresponding UI changes are done, all the rendering is done before you take the snapshot. And you can basically do it with assertions, with any assertion your testing framework provides you. In this case, I'm using the assertion to wait for the loading indicator to disappear. So I'm basically waiting for consistent snapshots. And I would consider that a general best practice in E2E testing, not only limited to visual tests. So please be nice to me if I'm a bit annoying on this topic when it comes to pull requests or being a reviewer, but it's really important to take care of your waiting times, not waiting too much, and even more, not waiting too less time. All right, this trap is a tough one. You might not see it at first sight because you could think, yeah, it's a login screen with a picture, right? It's the actual login screen of the Shopware 6 administration UI. So it's an administration UI for an online shop. And this image is the problem because it's depending on the time of the day when you load this login screen. So there are different images available depending on the time, like an image pool. And the image ending up here will be randomly selected from this image pool. So you can expect that this image will be a completely other image next build. Wonderful, right? Love it. Another quite typical e-commerce case, like if you have an online shop where people order stuff, you will have a time specification of the server on this order. It's the exact time when the order was done. And in software, it's read-only. So I'm basically talking about things who change after some time, which are server-sided and read-only. So you cannot influence it via test fixtures or client-sided or anything. And even more important, they are by purpose. So those known changes will take effect again and again and again, and basically every build. We need to deal with that. We don't want to be notified about that, right? Yeah, so Percy and the Visual Regression Tracker can offer you tools to support you in dealing with this challenge. And the most will target to ignore those changes. In quality, for example, when it comes to the Percy, where you can ignore the diff size. So they have a pixel threshold you can set, and you can define some fuzziness. Again, a little warning. You need to be aware how much fuzziness you set. So you are basically defining when the diff should be triggered, and if a little difference of just one pixel doesn't care for your it does. So you can set that. But you can also even ignore complete areas or elements when it comes to the service, as you see here with the Visual Regression Tracker, but also in configuration as well. You can intervene in CSS to ignore areas, for example, using display none as I do here with this little iframe example. You can do it when it comes to Percy by using the Percy command and defining it there, or using a configuration file. And if that's not enough, you can write your own command doing that. Here's the example how I handle it with this annoying little image in the login screen. I want to set another fixed background image, which will be always the same. So I write my first own command and invoke the styling I need. So I will change the app through the test. For example, you can do that with the order time as well, setting the color of the font of the time to the background, basically making it invisible, which sounds quite stupid, but it actually works in some cases. But no matter which option you choose, you really need to cover the elements you are actively changing with own tests, for example, an end-to-end test or a component test, so you won't hide a bug. And you need to document those changes as well, because if another person sees this screenshot comparison and sees that an element is missing, he might interpret it as an actual error, right? Alrighty. Our Cypress tests, or basically any of our tests, became detective now. In my case, let's call them Sherlock Cypress, right? Because it's cool. Sherlock Cypress is able to spot the different puzzles. And that sounds quite stupid, but it gets the test a bit closer to us humans, so that the test, which is basically still a machine, can be a bit more like an actual human and interpret tests the way we do, or UIs the way we do. And believe me, this can be a lifesaver if you think of bugs which were caused by side effects because we, for example, did a later refactoring and didn't consider a complete different module or a different thing. Such visual testing will catch those side effects. So I can say both tools can work quite well for me. Some in small, some in a bit larger projects. It will fit well into your infrastructure, even though it's just the example of Cypress or GitLab or GitHub. The integration is quite flawless, and there are possibilities to reduce false negatives quite well. And in both cases, there are free plans, and there's some support of open source. So I think it's a good thing to maybe give it a try to get started. When it comes to my talk and I need to choose 4 learnings which I want you to remember from it, it's these ones. Please consider giving your tests eyes. Teach us to look beyond its given path, beyond the concept, like a search puzzle basically. This can be achieved through visual testing, or simpler said, screenshot comparison. If you struggle to get consistent screenshots because of false positives or flakiness, it's totally okay to interfere with your tests and to fix it by doing so. Please just keep in mind to cover the original with another suitable test. Some tools as starting points could be the visual regression tracker or PerCIO, but there are lots of more other talks to consider. So yeah, I hope I was able to give you a little starting point to introduce you to the world of visual testing and to give you the possibility to benefit from their advantages. And what else is left to say by me then? Thank you. Thank you so much for listening to me and to discover visual testing alongside me. If you got questions, feel free to contact me at any time via Twitter, LinkedIn, or wherever you found me. And until then, see you and take care.